Well, hello. I literally just finished the 1.6 notes, and now I'm headed right into the factoring overview. And like I mentioned at the tail end of the 1.6 notes, I have posted a note sheet that kind of does an outline of all the different types of factoring that we're going to talk about. And it discusses in depth how to go through the factoring. So you're welcome to pull that up. I recommend having it for when you're going through these examples. And while I'm working them, you can kind of see the steps being worked as we go. So I'm going to do some examples of each one of the types of factoring that you're going to see. I'm going to start with greatest common factor factoring, which is the first type on that sheet. And it discusses how to find the greatest common factor and what you have to do once you find it. So I'm going to just do a couple examples here of GCF factoring. Let's say we had something like 8x to the 5th plus 12x to the 3rd minus 4x to the 7th. So here's my polynomial, and it contains powers ranging from 5, 3, and 7, and it's got a bunch of coefficients. What I'm really looking for is what can I divide out of all of these terms? That is what the GCF is, what we can take out. So I consider everything separately. I start with the coefficients. So I want the largest number that divides into 8 and 12 and negative 4, which is going to be 4. And then I consider the variables separately. And as long as all of the terms contain the variable, you take the lowest power that you see. So in this case, it would be x cubed. Now, the notation when you factor out a greatest common factor is to put the GCF in the front of a parenthesis and then fill the parenthesis up with the quotient that you get when you divide it out. So I'm going to go through and divide this thing out. 8 divided by 4 is 2. X to the 5th divided by x cubed is x squared. 12 divided by 4 is 3. X cubed divided by x cubed actually just cancels, so there's not going to be a variable in that term. Negative 4 divided by 4 is negative 1. And then x to the 7th divided by x cubed is x to the 4th. And that's way too far over, but you kind of get the idea. Where's my eraser? I'll get rid of it and fix it. So whatever's left over once you complete all the division is what goes inside the parenthesis. Sometimes you might run into a situation where you have more than one variable in there. You might see something like 10 a cubed b to the 5th plus 5 a to the 4th b squared minus 20 a to the 9th b cubed. I don't know, something like that. And even though there's more than one type of variable, you still do the same thing that we just did and consider them all each as like individuals. We start with the coefficients. 10 and 5 and negative 20 all have a 5 in common, so 5 is a part of the GCF. Between the a's, I've got a cubed, a to the 4th, a to the 9th, so the lowest power is a cubed. And then between all the b's, I've got a 5th, a square, and a cube. That's going to give me b squared. So that's what goes on the outside. And I'm going to divide each one of these terms by 5 a cubed b squared. And then I'm going to go through and do the same thing that I just did, except it's a little bit more in depth because I've got extra variables, but that's okay. Starting off, 10 divided by 5 is 2. The a cubeds cancel. b to the 5th divided by b squared is b cubed. Then I've got 5 divided by 5 is 1, which we don't write. We don't write a 1 coefficient. A to the 4th divided by a cubed is a. And the b squareds cancel. And then I've got negative 20 divided by 5, which is negative 4. A to the 9th divided by a cubed is a to the 6th. And b cubed divided by b squared is b. If you're wondering where I'm getting all of these powers on my variables, the powers are coming from subtracting the exponents. Top exponent minus the bottom exponent. And if the exponents happen to match, then in that situation, they actually just cancel each other out. So that's where that stuff is all coming from. And that's GCF factoring. Now, the next type that we're going to talk about is factor by grouping. Now, grouping just takes the concept of GCF factoring and kind of like applies it twice. And it's very important to note that grouping is done in polynomials that have 4 terms. So when you have a polynomial with 4 terms, it should send up a big red flag that you're going to be factoring by grouping. So it's going to look something like this. Let's say we had x cubed plus 5x squared minus, let's do 8x minus 40. So something like this. Important side note, anytime you're doing factoring, you want to make sure that you look at the polynomial as a whole in its entirety so that you can determine if there is a GCF of the entire thing. Because if a GCF exists in the entire polynomial as a whole, you have to pull it out before you do anything else. This one is not going to have one, and the next one won't either because I want to actually get to the grouping part. But it is important to make sure that if it has the GCF of the entire thing, you pull it out first. Now, this one doesn't, so we can get into our grouping. To factor by grouping, you begin by grouping the first 2 terms and the last 2 terms together, essentially creating 2 separate binomial expressions. So I've created x cubed plus 5x squared, and I have created negative 8x and negative 40. We're going to consider them separately while we're going through and doing our factoring. And what we're trying to do here is find the GCF of each one individually and factor it out. So I'm looking for the common factors in each parenthesis. In the first parenthesis, I've got a common factor of x squared. When I divide out x squared, I'm left with x plus 5. In the second one, I have a GCF of negative 8. I divide it out and I'm left with x plus 5. Now, if you forgot to take out the negative in that step, what would end up happening is that your signs in your parenthesis would be flip-flopped from the signs in the original parenthesis. And when that is the case, you should recognize that just the signs are flopped and you probably want to just pull out a negative and it will fix that problem. So in this case, we took out the negative 8, so we're in good shape. Now, once you have the GCFs factored out and you notice that your parentheses match, which is what they are supposed to do, you know that you're in good shape to continue your grouping. If they are not even close to matching, it's probably because the polynomial is not factorable. Polynomials that are not factorable are called prime polynomials. This, however, is factorable. The parentheses match. So what we're going to do is notice that both of these terms have a common factor, x plus 5. So essentially what we're going to do is factor out the x plus 5 from each one of these terms. And when you factor out a GCF, it goes in the front of a parenthesis all by itself. So x plus 5 goes in the front. Now we've got these two chunks here left over, kind of just floating around, and they don't have anything to do. So it's probably a good idea to just put them together in a second parenthesis so that they're not lonely and they have each other. So now we've got x plus 5 and x squared minus 8. Please note that you can check all of your factoring by going back and foiling these things back out. If you FOIL it back out, you should get the original equation. And if you don't, the factoring went wrong somewhere, or maybe you didn't multiply right, but you can check all of them. So this is factor by grouping. Now we're going to get into some trinomials. Trinomials are polynomials in the form ax squared plus bx plus c. A, b, and c are just real numbers, and the highest power is going to be a square. If it's higher than a square in this class, it's probably because it can be factored and reduced. But for now, it's going to be squares, or something that, like I said, can be factored. There are three types of trinomials that I like to talk about, and I separate them out as such so that it makes it easier to kind of get the hang of it. So the first one I'm going to call type A, and in a type A trinomial, the leading coefficient is 1, the last term is positive. That's what makes it a type A trinomial. So type A trinomials look something like this. X squared, let's do plus 13x plus 40. Let's do x squared minus 12x plus 11. And then let's see one that has some coefficients in it. Let's do 5x squared, and then plus 25x plus 30. Now we'll talk about why number 3 is still a type A in just a second, but I want to talk about the first two first. Again, what makes a type A is that it has a leading coefficient, leading coefficient of 1 and a last term that is positive. Now, when you are factoring type A trinomials, you are looking for factors of the last number that add to give you the middle number. So two numbers that multiply to give you 40 and add to give you 13. Another important part about type A trinomials is that both of the factors have to take the same sign, and the sign depends on what's happening in the middle. If the middle sign is positive, both of the factors are positive. And if the middle sign is negative, they're both negative. So it will just kind of depend. So what I want to do is find two factors that multiply to give me 40 and add to give me 13. So if you're not real comfortable with this, you can list them all out. 1 and 40, 2 and 20, 4 and 10, 5 and 8. And you just stop whenever you get to the appropriate factor pair. In this case, 5 and 8. Because 13 is positive, they both need to be positive when we put the notation in the parentheses. Order does not matter. You can do the 8 first or the 5 first. It makes no difference. But it does matter that the signs are correct. So both of them positive. The notation is 2 parentheses. Whatever the variable is here is going to split and go in the front. And the factors that we just found are going to go in the back. Again, any order, it doesn't matter. Plus 5, plus 8. And there's your factored form. Also, x plus 8, x plus 5 is just fine. Number 2, similar, but not exactly the same. We start off with x squared minus 12x plus 11. I need a factor pair of 11 that adds to give me 12. Now, lucky for us, there's only one. It's 1 and 11, and that does happen to add to give me 12. But this time, 12 is negative. So in order to get a negative there, I need to make sure both of my factors are negative. X minus 1, x minus 11. Order doesn't matter. Now, number 3 doesn't look right because number 3 has a leading coefficient that is not 1. So we have to be able to do something else here in order to turn it into a type A. And what we should notice is that there's a GCF here, and it happens to be 5. The only way that this could be a type A trinomial is if it could have the 5 factored out, and it can. So we factor out the 5 first. I'm left with squared plus 5x plus 6. And now what's left in that parenthesis is a type A trinomial. So I need factor pair of 6 that adds to give me 5. 1 and 6, 2 and 5. No, 2 and 3. Now, out of those two factor pairs, 2 and 3 are the ones that add to give me 5. 5 is positive, so both positive. And now we put it all together. The GCF stays out front. Notation, x plus 2, x plus 3. So here's my type A trinomials. And again, type A's are going to have a leading coefficient of 1, or it would be able to be factored out. And then also, once you do that, you have to find factors of your last number that add to give you your middle number. All right, so that's type A. Let's look at type B. Type B trinomials look very similar to type A trinomials. There's just one key difference. And again, this is on that overview sheet that I posted. A is still 1, but in this case, C is negative. So when you're dealing with type B trinomials, the way you find your factors is a little bit different than the way that we find our factors in a type A. In a type B trinomial, you're looking for factors that subtract to give you the middle term. Also, it's very important that when you're factoring a type B trinomial, you use opposite signs on your factors. The larger factor will take the sign of the middle number. The other factor will take the opposite sign. So let's look at some of these. I'm so lazy, I always use x. Let's use n. N squared minus 2n minus 24. Let's use a squared. I don't like using these other letters, but it's fine. Minus, no, you do plus 7a minus 60. Let's do, I'm going back to x. Let's do x to the 5th. And again, we'll talk about this in a sec. I know I said squares, but now we're just going to throw a 5th in here and we'll see. Let's do x to the 5th minus 4x to the 4th minus 21x cubed. So 1 and 2 look pretty much the way that they should, but 3 looks a little bit off. We'll talk about it in a second. So let's do our factoring here. What color do I want to use? Let's use pink. Did I use pink last time? I did. All right, well then let's not use pink. I don't know why I care, but we'll use this teal color. All right, so I want factors of 24 that subtract to give me 2. Again, you can write them all out, or some people can just come up with them really quickly, whichever way you have to go. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Out of these factors, the set that subtracts to give you 2 is 4 and 6. The larger of the two factors will keep the sign of the middle, which in this case is negative. So my larger factor takes a minus, smaller factor takes a plus, and the notation is the same as it was, n plus 4, n minus 6. Order doesn't matter, appropriate signs matter. So as long as the 6 is negative, you can put it first or second. Factors of 60 that subtract to give me 7. 5 and 12. This time 7 is positive, so 12 better be positive, which means 5 has to be negative. A minus 5, A plus 12. Oh, better put some parentheses in there. And then this last guy here, he doesn't look right, because in this last guy, we start off with an x to the 5th, and that's no good. We're supposed to start off with an x squared. But if you look at each term, you should notice that each term contains an x cubed, which means we have a GCF. And anytime we have a GCF, we want to make sure that we pull out the GCF before we do anything else. So that x cubed is going to come out. It's going to change the way this looks. X cubed divided out, we've got x squared minus 4x minus 21. Now what's left over in that parenthesis is a type B trinomial. So I need factors of 21 that subtract to give me 4. The factors of 21 that subtract to give me 4 are 3 and 7. 7's bigger, so 7 better be negative. X cubed on the outside stays there. X minus 7, x plus 3. And so there's your type B trinomials. Now I'm going to have to stop here and take a little break because I have to go to a class at 2:30. So my plan is to go to my class, teach that class, and come back and do the last few types, which are type C trinomials and differences of squares and differences of cubes. So look for another video that's like factoring part 2, and that will have kind of like the tail end of all of this stuff so that you can see excuse me, how the rest of the types are factored. But this is a good start. So when I get back, I'll post another video that will detail how to do the rest of them. So sit tight. I'll see you in a minute.